Hello, everyone. We're going to start our third lecture today, and we're going to talk about matrices and matrix operations. So in our book, it's section 1.3. And matrix operations. So we're going to start with definition, a little review. What is a matrix? Matrix is a rectangular array of numbers. So the numbers are called entries. And a couple of examples. For example, we have a rectangular array of 4 numbers, 1, 2, 3, 0. So each number here is entry. Also, arrays can look like just lines or rows. This is a row matrix, right? Also, arrays can look like columns. This column matrix. And in general, we're going to label matrix with big letters, capital letters, and in the bottom, we are going to show indexes, which are going to mean the size of the matrix. So if we do have matrix, it's going to have m rows. So it's kind of vertical dimension of the matrix is m, and n columns. Horizontal dimension is n. Each entry is going to be labeled by 2 sub-indexes, and the first is going to mean row, and the second is going to mean entry. For example, the entry 2, 3 is going to be located in row number 2. So that's the first row, that's the second row, row number 2, and the column number 3. So that's the first column, the second column, and the third column over here. And there is going to be the entry, which we are describing. Okay, usually, guys, we are going to label arbitrary entry as A, I, J. Something like this, A, I, J. Okay, and what is next? Well, now, like matrices are going to be our objects. We are going to deal with them. And one of the first thing is how to compare two matrices, like if matrices are equal or not. Two matrices are equal if and only if all entries are equal. So for example, we have matrix 1, 2, 3, 4, and another matrix 1, 2, 0, 3, 4, 0, 0, 0, 0. And it looks like essential entries are equal, but there's a bunch of zero entries, which are going to make these two matrices not equal. Well, the first equal matrix is supposed to have same size, same shape. Now, how do we add matrices? Matrix addition. So imagine that we have matrix A and we want to add to matrix B. So what we are going to have is matrix C. How are we going to get elements of matrix C? C, I, J, element which sits on the place I, J is going to be equal A, I, J plus B, I, J. So we are going to add two matrices, element by element. And of course, subtraction is going to look exactly same. If you wish to subtract, we are just going to subtract elements. And I don't know, let's try to subtract or add two matrices. Forgot to mention matrices must be the same size, the same shape, same size, same shape. So Well, let's imagine that we do have matrix 1, 2, 3, 4, 5, 6. And that's going to be my matrix A. We also have matrix B. 1, 0, minus 1, 0, 1, 0. Oh, kind of more simple. We see that the shape is the same. So we have 2 rows, 3 columns, 2 rows, 3 columns. We can try to add these two matrices. So what we need to add, 1 first element and 1 over here is going to give us 2. 2 and 0 is going to give us still 2. 3 and minus 1 is going to give us 2 again. Right? And 4 and 0 is going to stay 4. 5 and 1 is going to become 6. And the 6 and 0 is going to stay 6. And that's going to be the sum of these two matches as well, kind of difference. If you want to multiply matrix by a scalar, multiplication by a scalar, I'm going to label it as C. What is scalar? Scalar is just a real number. Well, to multiply matrix by a scalar, we're going to write it down like this: C multiplied by A, and elements of my new matrix are going to be, well, I'm going to label, for example, B equals this. C scalar multiplied by matrix A. Elements of matrix B, IJ, are going to be that scalar multiplied by elements of matrix IJ. So basically, you multiply every element. For example, I'm going to use matrix A from my first example and going to multiply it by 2. 2 multiplied by A. How my elements are going to look. Well, each element is going to be doubled. So it's 2, 4, 6, 8, 10, 12. That's going to be 2. Now we can combine these two operations together. We can add, subtract, or multiply by a scalar, which is kind of not difficult, right? The last operation we are going to learn about matrices is how to multiply two matrices. So far we multiply matrix by a scalar. Now do we multiply two matrices? Matrix, and that's going to be a separate topic. Matrix, oh, sorry. Something happened to my thickness. Okay, matrix multiplication. How do we multiply two matrices? Well, the expression of matrix multiplication is not going to be very, very kind of simple. So I'm going to start maybe with a picture, then example, and then the final formula. Okay, imagine that you want to multiply two matrices, matrix A by matrix B. I'm going to draw them as two pictures. This is going to be the picture of matrix A, and there's going to be the picture of matrix B. Again, we do create this rule. It does not exist in nature naturally. We create it as a rule. So how are we going to multiply? To get element of the product, let's label it like C. To get element C, I, J. What we are going to do, guys? We are going to take row I from the first matrix and the column J from the second matrix. And we are going to multiply them entry by entry. We are going to multiply first entry by first entry, the second entry by the second entry, and then we are going to add them together. If you write it down as a formula, it's going to look like this. My element of matrix A with row number I and column number 1 is going to be multiplied by element of matrix B with row number 1 and the column number J. And we are going to repeat this operation for like all elements which are sitting here and all elements which are sitting here. So for example, next one is going to be AI2 by B2J and AI3 by B3J. And until you kind of finish with both matrices. Well, I don't know how many elements we have, but let's imagine that our last one is kind of K. So AI K by B K J. Okay, that's how we build the element. Important. Well, to make sure that the sum or the rule works means that we'll need to make sure that number of elements in a row is the same as number of elements in the column. And if we have like 5 elements here, it's supposed to be 5 elements here, which means that the certain dimensions of matrix A and B supposed to match. We're going to talk about this a little bit later. But before I move to real example, I want to write down this formula in the sigma notation. So what I'm going to do, guys, I'm going to put A, I, K by B, K, J. And I'm going to use index K as a summation index. Well, maybe K is not a good idea because I labeled my top like the dimension as K. Well, let's use a different letter, M. Just a second. I already used K for dimension. I, M, B, M, J, and the summation index M is going to be from 1 to K. So we are going to sum up the products of like I1, 1J, and until your M reaches last element. So let's see how it looks in real life. And then maybe have some practice. So I'm going to multiply 2 simple matrices. I'm going to use one of my old matrices. 1, 2, 3, 4, 5, 6. And my matrix B is going to look slightly different. It's going to be looking like 1, 2, 3, 4, and 5, 6. Let's first look. Can we do actually the product? Let's compare number of elements in the row and number of elements in the column. So in the row, we have 1, 2, 3 elements. In the column, we also have 3 elements. So we are okay. We will be able to perform operation. Well, let's start. Imagine that we want to calculate matrix C, which is a product of 2 matrices A and B. So I'm going to calculate element C11. C11 is going to be a product of this first row by first column, and I'll need to multiply them element by element. So it's 1 by 1, 2 by 3, and 3 by 5. So we multiply elements and then add them up. What we're going to have 6, 7, and 15, so kind of 22, right? That's my first element. C12. So we're going to use row number 1 and column number 2. I'm going to circle it, 2, 4, 6. So we're going to multiply 1 by 2 plus 2 by 4. Sorry, 2 by 4 and plus 3 by 6. And that's 2, and that's what? 8, so 10, and 3 by 6, 18, so kind of 28. Okay, next element. We multiplied the first row by both first column and the second column. Now we are going to move to second row. Repeat operation. First column and the second column. So 2, 1. Row number 2, column number 1. 4 by 1 plus 5 by 3 plus 6 by 5. And that's going to be what? 4 by and plus 15, 19, and plus kind of 30, right? So it's 49. hopefully I'm not doing a mistake anywhere. And the last element, C22, that's a second row by second column. 4 by 2 plus 5 by 4 plus 6 by 6. So we have 8 plus 20, 28, and 36. So we have 64, right? 64. Hopefully I'm not missing anything. Okay, so now how matrix C is going to look, considering all these numbers, and maybe it's going to have more out. So that's going to be matrix C. 22, C11, C12, first row, second column is 28, and then 21, 49, and then 22, 64. And that's going to be my matrix C. Well, let's talk about dimensions of the matrices. Which dimension is supposed to match? Well, imagine that matrix A has dimension m n multiplied by matrix B with dimensions all k. So, since we need the same amount of elements in a row, which is equal to number of columns. Number of columns is here. And we need the same amount of elements in a column, which is amount of rows. Amount of rows is over here. So these two numbers must be equal. Two other numbers don't need to be equal, and actually resulting matrix is going to have dimension m by k, missing like or three not restricted dimensions. Well, we probably see. So we had matrix A was 2 by 3. Matrix B was 3 by 2. And the resulting matrix C is 2 by 2, you see? So dimension 3 cancels and 2 outer dimension stays. So this is outer dimensions. What is interesting, guys? In general, product of two matrices does not commute. So actually, A multiplied by B is not going to be equal B multiplied by A. And sometimes you won't be able even do multiplication itself. So let's imagine that you take the very same matrices and put first B and then A and decide to multiply them. Matrix B, 1, 2, 3, 4, 5, 6. And matrix A, 1, 2, 3, 4, 5, 6. You start multiplying these two matrices, and well, these two matrices are still going to work, right? But let's calculate our first element. It's going to be 1 by 1, 2 by 4, which is going to be 9. So my first element is going to be equal to 9. If you compare it to my first element of this matrix, is equal to 22. Well, besides that, elements are going to be different by themselves. What is going to be resulting dimension of this product? Well, let me write down dimensions. 3 by 2, 2 by 3, right? Remember that this inner dimension is going to disappear when you do multiplication, and only outer dimension is going to stay. So the resulting matrix is going to have 3 elements here, 3 elements here. So it's going to be actually matrix 3 by 3, totally different from 2 by 2 matrix in the first case. So product is in general not equal, can give you a totally different matrix, and even can sometimes does not exist just because dimensions matrices in different order do not match. Okay. I think let's stop at this point and kind of Let's have the rest in the next lecture. Give me a second, guys. I'll figure out how to um, stay. Sorry.